Hello, Nari McDiarmid with you for Mining Magazine, and thanks for joining us for the second in our three-part series with Atomionics. Now, in this episode, let's break down the science behind the exploration solutions with Dr. Ravi Kumar, who's co-founder and Chief Technology Officer. Ravi, in simple terms, can you please explain quantum sensing and what this does in terms of helping exploration?
Thanks a lot for having me. When we talk about quantum sensing, essentially we are talking about using principles of quantum mechanics to create instruments of extreme precision. Quantum mechanics gives us remarkable phenomena like Heisenberg's uncertainty principle, quantum entanglement, or wave particle duality, something that we use to build our devices. The key idea was proposed by Louis de Broglie about a century ago that all matter has both particle like and wave like properties. Even atoms can behave like waves. This wave nature allows us to build what's known as matter wave interferometer. To achieve this, we first trap atoms inside a vacuum chamber that has vacuum levels comparable to deep space. Then, by shining lasers on these atoms, we slow them down and trap them at the center of the vacuum chamber, a process called magneto-optical trapping. This gathers like hundreds of thousands of atoms into a tiny cloud about a millimeter across. At that stage, their wave-like behavior become accessible, and we use it to create an interferometer. This lets us measure tiny variations in gravity with incredible accuracy, which in turn reveals what's hidden beneath the ground, which directly translates into better mapping for mineral deposits.
So, Ravi, this is obviously highly technical and very different to just putting a drill rig out on your exploration tenements. So, how is this transforming mineral exploration and evolving from those traditional methods?
Our instrument, which we call Gravio, is designed for gravity measurement, a fundamental technique in exploration. Traditionally, field deployable gravimeters have been spring based devices. While they work, they suffer from drift, meaning the same location may not give the same reading over time. To correct for that, operators need to take repeated measurements and cross reference them with a calibration site frequently, which slows everything down. The way that these devices are deployed is also very time consuming. Typically, you set up the gravimeter on the ground, like wait for 10 minutes for it to stabilize and record one reading, and then move to the next spot. And you repeat this process like every few hundred meters for thousands of kilometers. The end result is a gravity map with a very low resolution. Each data point effectively represents an area about the size of a football field. With Gravio, the process is completely different. No ground crew is required as we don't need to put anything on the ground, which reduces safety risks on operations in the outbacks. We mount the gravimeter inside a van and keep moving across the survey areas. We don't need to come back to the calibration site as the data we collect is absolute rather than relative. This allows us to cover big areas far more quickly with orders of magnitude better spatial resolution. Instead of a football field, each pixel on the map is now closer to the size of four pizza boxes. That means we can see underground features in far greater detail. We then process this data with our interpretation platform, which uses machine learning techniques to analyze geological patterns. By combining high resolution data that we acquire from our devices with intelligent pattern recognition, we are able to generate far more accurate drilling targets. This not only pinpoints the exact location where the valuable minerals are present, but also provides critical insights into their potential quantities, optimizing exploration efforts and minimizing unnecessary drills.
So, Ravi, what are some of the advantages of using this technology?
The first advantage is speed. Surveys that would have taken like years for conventional techniques that can be done now in like weeks or months. Another one is certainty. With much higher resolution, we can pinpoint targets with a level of confidence that simply wasn't possible before. Instead of drilling almost blindly across like very broad areas, exploration team can go directly to the most promising spots. And third is efficiency. Drilling is expensive and environmentally disrupted. Traditionally, companies have had to drill many holes to locate any viable deposit. With our technology, we can cut unnecessary drills by as much as 90%. That saves enormous amounts of time and money while also reducing the environmental footprint of exploration.
Well, in terms of another evolution, can you tell me how your technology has evolved over time and where you see it headed?
When cold atom systems were first developed, they were strictly lab based. A typical setup occupied an entire room, a large vibration isolated optical table, racks of electronics, laser, vacuum components, other mechanical components. They were never designed with field deployment in mind. Our first step was to shrink all of that into a portable package. Initially, we built systems that fit into a trailer. From there, we managed to miniaturize further so the device could be installed in any standard commercial van. That's when we could finally take it into the field for mineral exploration. The next step in our roadmap is drone based deployment. By mounting the system on drones, we will be able to survey areas that are inaccessible by vehicle, like rugged terrains, dense forest, or places where on ground surveys are impractical. This opens the door to exploration at a scale and a speed that has never been possible before.
That's quite a change from equipment that takes up an entire room to something that could be carried by a drone. Ravi, thank you so much for your time today.
Thank you. For us, it has been a really exciting journey, turning complex lab systems into a rugged field instrument. The fact that these sensors can help exploration companies make faster, smarter, and more sustainable discoveries is very rewarding. We believe this technology has the potential to fundamentally change the way mineral exploration is done today. And that keeps us motivated and keep innovating.
Thank you. And we will take a closer look at the potential impact in the next episode.